the one sample t-test, I have shown you the hypothesis. So here you can see, in case of independent samples t-test, we are comparing the mean of the two different populations, right? Or you can say, using the sample mean, we want to say whether the two samples are coming from the population which are having almost similar means or not, right? So we are making the null hypothesis as mu1 is equals to mu2. That is, population 1 mean is equals to population 2 mean. Alternatively, we are saying population 1 mean is not equals to population 2 mean. So when I say not equal to, means possibility is this can be either greater than or it can be either less than. So both the directions can be possible here. So we can call this test as a two-tailed test, right? But when we are clearly mentioning whether the first population mean is less than or greater than, this will be the case of one-tailed test, right? So as yesterday I have shown you these, what I can say, the normal distribution curves. So according to that, if you are talking about the two-tailed test, so generally your rejection reason is falling on both the tails. But whereas when we are talking about the one-tailed test, the rejection reason will fall on the either of the tail, right? So this is, I think we have discussed this concept. I discussed yesterday also. So till here, is any problem? Is there any problem?
No.
Fine. Further, talking about the same thing, if you do not want to express or present your null hypothesis in the symbol form, if you want to write them in a statement form or in the text form, you can write your hypothesis like, there is no significant difference in the group 1 mean or group 2 mean. Or you can say group 1 mean is significantly less than or equal to group 2 mean, or group 1 mean is significantly more than or equal to group 2 mean. So the first case, this one, this is a case of two-tailed test. This is a case of one-tailed test, right? Is it, I hope, clear? Yesterday also we have seen the similar kind of things. Any doubt?
No doubt.
Fine, thank you, ma'am. Now, other way around, you can also write your null hypothesis like this, that mu1 is equals to mu2. I have already shown you, but you can also write mu1 minus mu2 is equals to 0. This will be your null hypothesis. Means when both the means are same, that means the difference of them will be 0. Or other way around, you can say when mu1 is not equal to mu2, that means the difference will also be not equal to 0. Right? Fine, I hope. I think there is a problem. Whose mic is on?
Off कर दिए मैंने.
Okay. Thank you so much, sir. Fine. So till here I am clear to everyone. May I proceed? Fine. Say yes or no, friends. I hope I'm audible, everyone. Hello.
Yes, ma'am. Yes, ma'am.
Yes. Further, now when we talk about the manual procedure of applying the independent samples t-test, like yesterday we have seen for the one sample t-test, you can find usually you always needs to define your null and alternative hypothesis. Then you are setting your level of risk, that is the alpha value, that is the 1%, 5% or 10%. These are the most used percentages, right? Then we need to calculate the degrees of freedom, which is generally n1 minus 1 plus n2 minus 1. That means the sample size of the first sample means how many persons are there in a first group minus 1, how many persons are there in a second group minus 1. And the addition of these two will give you the degrees of freedom. Then you need to state the decision rule. Generally, this I have mentioned in case of the manual calculation. As I told you previously that in case of manual or in case of the comparison of the calculated and tabulated value or the critical value. We are comparing these two and deciding whether we are accepting or rejecting the null hypothesis. So when your calculated value is less than your critical value, you need to accept your null hypothesis, right? This is at the 5% level of significance. And for whatever number of degrees of freedom you will get. Then you need to calculate the t value. So generally this is the formula manually we are using to get the t value. And here SP is the pooled standard deviation or pooled variance if it is square. So in that case, we can use this particular formula to get the SP, and that way we can put here, replace remaining values, take a square root of this, will return us the T value, right? Now, if because in the previous case, this is the pooled standard deviation which you have written here. So you can find here when we are saying this thing, that is standard deviation of both the samples is same. So this is giving you the pooled standard deviation. But when the standard deviation of both the samples are different, you can find S1 square, S2 square. In that case, you need to take the degrees of freedom formula like this, right? So accordingly, you can take that, and that value will help you to get the critical value or the table value of T. So this is the manual process. And suppose, I think I tried to take one example for you. This is only you need to assume, suppose using your data, you have calculated the T value. And if suppose it is coming as 1.78 and you want to, or you're testing your hypothesis at 5% level of significance, and suppose the degrees of freedom is coming as 12, right? So for the 5% level of significance, which is this, for the 12 degrees of freedom, which is this, you can find the T table value or T critical value will be 2.179. So you can compare these two figures. So it is quite visible to everyone that 1.78 is less than 2.179, right? So we can accept the null hypothesis. So this way we are performing manual calculations and we are reaching to the conclusion. I think it is easy to understand, right? Any confusion, friends?
No, ma'am.
Fine. Now, the important part of the independent sample status, which is the assumptions part. So here you can see the assumptions. The very first one says the independent variable should be categorical. Means you need to have one categorical variable to perform independent sample status. So categorical meaning is what? This variable should be measured on the nominal scale or at max the ordinal scale and not more than that, right? So we will be having one independent variable, and in this independent variable, we need to have two groups, right? Two groups or two categories. And if suppose you are having more than two groups, so to perform t-test, priorly you need to decide in which two groups or in which two categories you want to make comparison, right? Second is the dependent variable should be continuous. Third, there is independence of observations. That means this you can maintain if you are collecting the data from one person only once. So that way the independency can be maintained. Fourth one is the dependent variable should be normally distributed. Means whatever is your numeric or continuous variable, it should be normally distributed in both the groups of the categorical variable, right? And the dependent variable has no significant outliers in either of the group. Means if suppose I'm having the male group and female group and I'm measuring the salary or comparing the salary of these two groups. So in either of the group, meaning is in the male group also and in the female group also, there should be no outlier available, right? In the salary variable. Then variances of the dependent variable in both the groups should be equal. So whatever is your dependent variable, the variance for the same should be equal in both the groups. This is known as homogeneity of variances. So these are the 6 most important assumptions which we generally check while performing the independent sample t-test. I hope all 6 are clear. Why people are so quiet today? Why people are not interacting? It is clear or not?
Yes, ma'am, clear.
Fine. So question comes, what if assumptions are not met? So there is a substitute available in the non-parametric test category named as Man Whitney U test, right? Further, this I have already shown you. This we are using for understanding the normality of the variable, means using the histogram we can comment on the normality. Then talking about the new assumption which you have heard today, which is homogeneity of variances, means for the dependent variable the variance should be same in both the groups, right? So for this assumption we are using the Levin's test, and here you can see the null hypothesis of the Levin's test is that says that this variance in the of the first group minus variance of the second group is equals to 0, or you can say variance of the first group is equals to variance of the second group, right? So this is population variance of both the groups are same or equal is known as the null hypothesis of the Levin's test. Vice versa, you can say it is not equal, right? So you need to test or check this particular hypothesis firstly, ascertaining the homogeneity of variance. If not, so in that case you can say the means data is violating the results, sorry, violating the assumption. Fine. Further, how to perform t-test independent samples in SPSS. This is the process which we will see further. So this is about the conceptual background of independent samples t-test. So far, any confusion you people is having regarding this?
मैम लिटिल 5 मिनट ड्यू टू सम इमरजेंसी कॉल थोड़ा सा ब्रीफ आउट करेंगे क्या? What
Yes.
I understood till the assumptions.
I think
Assumptions and
was the
table.
last thing, ma'am. Assumptions were
अच्छा,
the last.
assumption last.
Yes.
Independent t-test and formulas देखा मैंने, table देखा. Okay. Assumption एक बार थोड़ा सा brief out करेंगे.
I think we will see once we will check all
Okay.
the assumptions, right? So we will
Okay.
see in the SPSS, ma'am, one by one.
या श्योर. ये पिछला वाला स्लाइड एक बार दिखाएंगे. लेवर्स वाला क्या दिख रहा था? 1 मिनट. हाँ हाँ, ये क्या है?
This is the hypothesis, homogeneity of variances. Whatever is the last assumption for that, the hypothesis will be this.
Okay, so interpretation है उसका.
Means this is the hypothesis. Interpretation we will do in the SPSS.
Okay. ठीक है.
Fine, ma'am.
देखते. हाँ हाँ.
Okay. Anything else? Any query, friends? Shall I proceed?
Yes, ma'am.
Fine. So I think I shared with you the two sheets named, I think named as employee data, right? I hope yes, you have got the same. Friends, say yes or no. Shall I proceed?
Yes, yeah, I got this data. We got this data.
Over there and got them.
So friends, now in this particular data, you can find there are multiple variables available, right? And I want to say one thing on this online platform, all the data which I'm sharing, this is only the demo data, dummy data, right? You cannot use this data for your research purpose. Please do not do this thing. It is not ethical, right? I am only sharing the data with all of you for making you understand that how we can perform and how we can interpret such results, right? So you can note down the procedure, you can note down the interpretations, but please do not use the data for the research purpose. It is not like permissible, right? Now, here you can see multiple variables we are available with us. So you need to find the two variables. First is the gender variable, and second one is the salary variable. So here I want to compare the salary on the basis of gender, right? So can anyone tell me how or in which way I need to formulate my hypothesis?
Gender has an impact on salary.
Okay.
Has a
Fine.
positive impact on salary or has impact on salary?
Okay, okay, fine. Anyone else? Anyone else?
Gender and
That's-
salary are interrelated. Null hypothesis. Gender and salary are not dependent or interrelated to each other.
Okay, fine. Anyone else? Any other attempt?
Salary has no impact on gender.
Okay, I think two I have heard. I think one is said by Sanjana ma'am and second is said by the Debasis sir, I think, right?
Yes, ma'am.
Yes. Anyone else wants to say something? I think this is the right time you people need to tell you people. I think it is not like you people are learning, even I am learning from you people. So we are in a learning procedure. So if you will say, it will be helpful for you to understand the things. Anyone will attempt apart from sir and ma'am? Fine. So no issues. I think both of you have said almost similar thing, right? Okay. Before saying anything on this, I want to ask from each one of you available in the meeting that what is the purpose of t-test? I told you this thing in the yesterday's session also and at the starting of today's session also. What is the purpose of t-test? Why we are using t-test?
हाँ वही है कि सैंपल मीन और पॉपुलेशन मीन वगैरह को कंपेयर करना.
Okay, fine.
But not related to this. Yeah, we are not able to relate to this question.
Yes. Yes.
It is, I mean, what I could make out or gather is that t-test is used to test the hypothesis and come to a conclusion.
Sorry, Bachi. Sorry, sir. Will you please repeat?
Yeah, I'm saying that what I could gather is that t-test is used for testing the hypothesis and come to a conclusion.
No, I'm just asking the purpose of t-test. I know t-test is used for testing the hypothesis, but for what reason, for what purposes? Means we are having so number of tests available in statistics, but for every test there is a purpose that why we are using this test for this hypothesis. For every hypothesis, every test cannot be applied.
To validate the hypothesis.
I think, Sanjita ma'am, I think I'm able to
underside
properly.
to check the significance of the mean, whether the actual mean is different from the hypothesized mean.
Very good. I think it's Jyoti ma'am, right?
Yes.
Thank you so much, Jyoti ma'am. So, sir and ma'am, I was saying this thing. Purpose means there are so many tests available for. Means it is not like for any hypothesis we can apply any test. No, for each and every test is having its own, what I can say, importance for any particular purpose we are using it. So yesterday I told you for comparing the mean, and initially also I said this thing in this today's session that for comparing the mean we are using the t-test, right? So here we are having the gender and we are having the salary. So we do not want to see the impact here, or either we do not want to see the interrelation of these two. Now can you attempt that how we will make our hypothesis now? Anyone?
It can be like salary to the female. Mean salary to the female is more or less than the mean salary of male.
Okay, fine.
That way.
Yeah, I think this can be a one way.
Maybe this is a hypothesis that we want to compare the salaries.
Yes, yes, very correct.
Male salary is greater or less than.
Very correct.
When
Fine.
they are the two cases, it may be either greater or less than.
Very correct. Very correct. Good going, Poonam ma'am.
Yes, ma'am. Because it have the two tails.
Yes.
Either maybe less than or maybe the
No,
greater.
less than greater than if you are saying it is one tailed.
Okay.
When you are saying less than and greater than, it is one tailed.
Mm. According to that one, the t-test is performed.
Fine. Okay. So here I will convey my perception on this, that when we talk about t-test, as I said, we are comparing the mean. So I think it is quite obvious we cannot compare the mean of male and female. We want to compare the mean of salary for the male and female, right? So our null hypothesis can be there is no significant difference in mean salary of male and female employees. Can I say this? Anyone getting?
Yes, ma'am.
Making sense?
Yes, ma'am.
Yeah. So we can say there is no significant difference in mean salary of male and female employees. This will be our null hypothesis. Fine. Now, firstly, as I discussed the assumptions, so we will go one by one. So if I want to compare the salary as per the gender, so here we can say first two assumptions are talking about the variable, right? First assumption was we need to have one categorical variable, which will be independent variable with the two groups or levels. So you can find gender is a categorical variable, and in this variable there are two groups, that is male group and female group. So first assumption is checked or met. Second assumption was we need to have one dependent variable which should be numeric, or it should be on the interval or the ratio scale. So you can find here salary can be the numeric variable or the variable on the ratio scale, right? So we are having the second assumption also checked. We have checked it and it is met. So now first two assumptions were checked. Third assumption was saying there should be the independence of observation. So how you can check that? That means for a particular male or for a particular female, we have taken his or her salary only once. So that way third assumption is also checked by us. So first three assumptions, using your own observation, you can check. So there is no software required for the first three assumptions, right? Further, talking about the assumption of normality, outlier and homogeneity of variance, we need to depend on the software. So now we will use SPSS for checking the assumption. Till here, I'm clear to everyone?
Yes, ma'am.
Fine. Talking about the assumptions checking, so I'll ask you people, those who are performing, or maybe those who are noting down, they can note the steps, which is almost repeating we are, because already we have seen and done this thing. You can go to the analyze, descriptive statistics, and then explore. I hope not a big thing, not a big deal. It is very simple to understand. You can click on explore now. May I?
Yes, ma'am.
Fine. So here you need to shift your current salary, which is named as salary, in the dependent list box. Also, you need to select the gender variable in the factor list box. So dependent variable, we know it's a numeric variable, which is salary, and the factor means independent variable. So you are knowing this thing that you want to compare salary for the male and female. So you are shifting the second variable of your study, which is the gender, in the factor list box. I hope till here everyone is okay and with me, no problem.
Yes, ma'am.
Fine. Further, you need to go to the plots. Deselect stem and leaf, select histogram, and select normality plots with S. Tests done. Everyone, it is fine.
Yes, ma'am.
May I click on OK? Continue. Yes. May I press continue?
Yes, ma'am.
Okay. So apart from this, nothing we need to do. You can click on the OK to get the output. So I think without your permission, I did that so that we can proceed further and see the output. So now, first table is coming as a case processing summary. There you can find we are having the current salary variable, which is your dependent variable or numeric variable. And in the next column, you can find the categorical variable or independent variable with its categories is mentioned. How many female is there in the data? 216 and 258 are the males. Percent is 100. No missing value is there. Total is 216 and 258. Further, talking about the descriptive statistics, now descriptive statistics for the salary will be according to the two categories, that is female category and the male category. So in both the categories, you need to see that whether the salary is normally distributed or not. So I think you can recall we have talked about the normality using skewness and kurtosis, right? Apart from that, I told you generally mean, median, and mode all three are equal in case of the normal distribution, right? So you can find for the female, the mean salary is 26,031 point something, 95% confidence interval for mean. These are the two ranges. Trimmed 5% trimmed mean is 25,248. You can compare your actual mean with the 5% trimmed mean. 5% trimmed mean, if you can recall, I told you from both the tails, 5% data will be removed, and for the remaining 90% data, the mean will be calculated. So now you can find there is a difference in these two figures. It is indicating there are outliers available in the data, right? Median is 24,300. So again, you can compare mean and median. Both are not equal or not even nearby. So that means maybe it is an indication that salary is not normally distributed in the female group. Then variance is a very big figure. Standard deviation is 7,558. Minimum salary for the female is 15,750. For maximum salary for the female is 58,125. Range, you know, it is a difference of maximum and minimum. Interquartile range is Q3 minus Q1, which is this skewness and kurtosis. These are the two figures you can look at. So skewness is not zero. It is greater than zero and it is positive figure, right? Greater than zero meaning it is a positive figure. So you can say your salary for the females is positively skewed, right? That means there are very less number of female who are getting the higher salary, right? Kurtosis is 4.641. That means again, the threshold value for the kurtosis is generally 3, right? So you can see it is greater than 3. That means your data is leptokurtic data, right? Male salary, you can again read all the figures and that way you can compare. Broadly, if I say mean and median are not equal, right? 5% trimmed mean and the mean are, there is so much distance in these two figures. Skewness and kurtosis, again, you can see there is certain dilemma to comment that salary for the male is also normally distributed. So we will take the help of the next table, which is the Shapirovics test table. You can find here the significant value for both the female salary and for male salary. It is coming as 0.000. That means which is less than 0.05. So if it is less than 0.05, what I need to do? Need to accept or reject the null hypothesis.
Reject.
We will reject the null hypothesis. And what will be the null hypothesis? I think I told you the null hypothesis for the Shapirovics test. Yes.
There is no significant difference
Mhm.
in there is so the output will be there is a significant difference in the salary of male and female, or it is reverse.
Okay. The null hypothesis for Shapirovics test, I think people are not making notes. I told you the variable is normally distributed. This will be the null hypothesis of the Shapirovics, which we are rejecting. So that means we can say the
There
hypothesis.
is no difference. There is no difference in the mean of the.
No, we are not commenting on mean. We have not applied t-test.
Is not
In this case, the null hypothesis is rejected, and null hypothesis saying that variable is normally distributed. But we are rejecting that hypothesis, so we can say that the salary for the male and female for both the groups, the salary is not normally distributed. Getting me?
yes, ma'am.
Fine. Looking at the histogram for the female category, which you can see, which is indicating there are so many small bars coming at the right side. So there are less number of people, those or female, those who are drawing the higher salaries, right? Similarly, for the male also, it is true that there are very less number of males who are getting the higher salaries. It is again positively skewed. Then talking about the QQ plot for the female, that you can find, it is indicating that it is positively skewed. For male also it is positively skewed. You can, what I can say, you can skip this and coming to your box plots. So you can check your box plots at because in case of histogram we have seen there were very small bars were coming right at the right side. So that way you can find at the upper side of the box plots you are getting circles or asterisk, right? So in SPSS, circles can be accepted outlier, means these are not significant outliers, but the outliers which are shown by the asterisk sign are the actual or the significant outliers, right? So you can find here these are the significant outliers. That means these will impact your data, right? So either you can take a call, you can drop them, and that way again you can perform the normality testing, and you can ascertain whether the now your salary variable is normally distributed for female and male both the groups, right? So this is the one thing which I have told you. So till yet we have seen the what I can say assumptions till the point 5, that is the normality also we have checked, and also we have checked the outliers, right? The last assumption is remaining, which we can find in the results of the t-test. So once you will perform the t-test using the SPSS, that way it will show you the last assumption of the homogeneity or variances. Here till here I am clear. Why there is people are not responding today? What happened? It is fine, everyone.
Yes, ma'am. It is fine. You can proceed, sir.
Yeah.
Yes,
Thank you.
ma'am.
Thank you, sir. So if it is clear, so further we are now moving towards to the t-test to check the last assumption. So for the purpose, you need to go to the analyze, right? Go to the compare means and then select independent sample status. So I think I'm giving you the few seconds. You can also identify, locate the same, or if you want to take a pic or note down, you can do that.
Yeah, ma'am.
Done. Click on this. You would be on a independent sample status box. There in the test variable, this is asking you for your dependent variable, which is your current salary. You can shift it to this box. Next is the gender, which you can shift in the grouping variable box. So that means you are grouping your salary according to this variable, that is gender. Done. So once you have shifted it, you can find below this the box with previously which was not activated, it is now activated, right? Right. So you can click on this. Till here, everyone is with me. May I click on the define groups?
हाँ मैम, मेरा 1 मिनट मिस हो गया, वो मैंने फिर दूसरे डिवाइस से ज्वाइन किया, स्विच करने में ना वो मिस आउट हो गया। सो मेरा ये डायलॉग बॉक्स आया, एनालाइज एंड एनालाइज compare mean independent sample t-test, then gender, test variable gender, yeah.
Test variable is current salary. Grouping variable is gender.
Test variable. Yes, ma'am, done.
Done. Now below this define groups, button is activated, you can click on this. It is asking you to define your groups, right? So I think I am knowing this thing in this particular data, what is the groups, but I think you are not sure. You can cancel this. Now you can go to your actual file and go to the variable view, which is F, and the second group is the female group, which is M. So F and M are the ports which we have given. Right? The first group is the female group. You can click on the three dots. First group is the female group, which is F, and the second group is the female group, which is M. So F and M are the ports which we have given, right? This is what you have checked. After that, again I'm going to the analyze, compare, and then shifting into the group, putting first one, then you need to press continue. Okay, still you can check the percentages, which is 95%, that you can change at the output. Everyone has got the output.
Ma'am, can you put on the in the grid, right?
This is what you
If I have to go back.
done.
Yes, ma'am.
So after that, I think I'm coming on the output. I hope everyone has got the same output. Yes. Shall I?
Yes, ma'am.
Now you can
Yes,
see
ma'am.
the first table is the group statistics table, where you can find that for the current salary for the female and male, we are having total 216 females, 258 males. Mean salary for the female 26,031. For male, it is 41,441. Standard deviation is also mentioned for both the groups, and then standard error of mean is mentioned. Coming to the next table, which is talking about the independent samples t-test, there at the first section you can find the output of Levin's test is mentioned for the equality of variances. So to ascertain that variance is equal or not, we are using the Levin's test output, so that you can see the F value is 119.669 and the significant value is 0.000, which is less than 0.05. So you can recall the slide I told you. The null hypothesis in case of Levin's test was variance is equal, right? And we are rejecting that hypothesis. We are saying variance is not equal, right? So variance is not equal. That means this assumption also we have checked. So that means you can see when I talk about this table, you can find after the current salary, it is written equal variances assumed, and then the second section is mentioned as equal variances not assumed. Means even then, if your Levin's test, that is homogeneity of variances results, is not met by the data, even then you can proceed for the t-test, that you can check. The two sections are coming. So equality of variance is not there. That means you will not go in the first row. That means this is now the useless for you. You will not use the output of the first row now. We will go in the equal variances not assumed. And there you can find that t value is coming is minus 11.688 for the degrees of freedom to 344.262. And its p value or the significant value is 0.000, which is less than 0.05, right? So now you can see it, which is less than 0.05. That means you are going to reject the null hypothesis of the t-test, right? So you will conclude that there is a significant difference in the mean salary of male and female employees. That means the difference is significant, right? When you can compare the mean, you can find that the female's mean salary is 26,000 something, whereas for the male it is 41,441. So it is quite easier for you to now say this thing, that the male's mean salary is higher than female's mean salary. Getting me?
Yes, ma'am.
Yes, ma'am.
I think till here everything is clear to everyone. Any doubt in the independent samples t-test?
Ma'am, how you concluded कि अच्छा male average salary is more than the female average salary from the group statistics,
Yes.
from the mean itself, right?
Yes, because difference is existing. If difference is existing, so you can comment on the mean part, that which group mean is higher.
Yes, thank you.
Yeah.
So in this case, ma'am, just we have to check the value of mean only, the computed mean value.
Which case? In which case, ma'am?
मम्मी यही वाले for the ad case, just check the mean value of the male and the female.
After ascertaining this thing, means firstly you need to see whether the p-value is less than or greater than your level of significance. So this I'm talking about this section of the t-test. So in this case, you can find this p-value is less than 0.05. That means you are saying the that means you are saying that there is a significant difference is existing. So difference is existing. So now you can compare the mean. In which group that difference is, in which group the mean is higher or lower. You can say for female it is lower, for male it is higher.
Okay, ma'am. Okay.
Okay. Any other doubt?
Since p value is 0.000, that is why we will say this, right?
Yes, obviously, because it is less than 0.05. That means you are rejecting the null hypothesis. I think you need to understand, everyone needs to understand this thing. Null hypothesis is saying there is no significant difference, but we are rejecting that, whereas we are saying there is a significant difference. Means difference is existing. So now you can say that when you will look at your this mean value, so you can see this thing, that the difference is there. It is almost 15,000 rupees difference. That means I think it is coming here also. You can find after the significant values, we are having one more column for the mean differences, so which is coming as minus 15,409, because we are comparing from female to male. First group was the female, second group was the male. So 26,031 minus 41,441 is giving you 15,409, right? Which is indicating that female are having the lower salaries, lower mean salaries compared to male. And this is why we have gone for this. We have gone for this because of we are rejecting the null hypothesis of the t-test. Right?
Yes, ma'am.
Making sense, everyone?
Yes, ma'am.
Okay.
Yeah.
Yeah.
Main difference.
Further, any more doubt on this?
Ma'am, could you please explain equal variance assumed and not assumed?
Okay, fine. You can see the first section, Leven's test, right? Here the F test, Leven's test is what I can say represented by the capital F, right? Which is the Leven's test. Now, its significant value is 0.000. So you can make the note in your copy. The null hypothesis for the Leven's test is variance is equal, or there is equality of variances. That is your null hypothesis, right? So I think everyone is now what I can say very what I can say through with this concept, that when the significant value or the p value is less than 0.05, right, we are rejecting the null hypothesis. So I think when I said the null hypothesis is there is a equality of variance, so we are rejecting this. Meaning we are saying the variance is not equal. So here you can find SPSS itself is giving you, there are two groups, equal variances assumed. If suppose your null hypothesis is accepted in this case, so in that case you will go in the first row, you will report this t value, you will report this degrees of freedom, and you will report this p value. But equality of variance is is not assumed by us, because Levin's test is rejecting the null hypothesis of this test. So we will report the t value, which is this one. Degrees of freedom will be this one, and the degrees of freedom will be this one. Is it fine?
Thank you. Yeah, thank you, ma'am.
Yeah. Okay. Anything on the independent sample status you want to ask?
Yeah, no, ma'am. Go for the next one.
Fine. Thank you so much, sir. So this is about the independent sample status. I'll summarize at the end. We'll go for now the next topic, which is the paired t-test.
Yeah.
I think I shared the slides. It's visible.
Yes. Yeah, ma'am. It is visible.
Okay. So this is the second category of the two sample status, which is the paired sample status. This is also known as dependent sample status. So we can say the other name for the paired sample status is the dependent sample status. Now, when we are calling it this test as a pair, that means we will be having a sample and there will be a pairing, right? In case of independent sample status, we understood this thing where we will be having the two samples or two groups which will be unrelated to each other, or the two unrelated groups we will be having, or there will be no dependency of the one group on the other group. When we are saying paired sample status, there will be dependency, right? So what is the meaning of this test? We will be having only a single variable. Say, for example, I want to measure the effect of, suppose, BP tablet on the BPs of the patient. So suppose I am having 10 patients, right? So before prescribing the BP, we will be having the actual BP of the 10 patients, right? Then we will prescribe the BP tablet to them. And after a certain period of time, say for example, a 1 month or maybe 90 days or something, maybe we will again take their BP BP, what I can say, BP measurements, right? Yeah, BP measurements. And that way we will be having the grouping now. We will be having the previous BP tablet BP results or BP measurement for a particular person, and after the tablet also. So that way there will be a proper pairing. So in case of paired sample status, it is very essential for us that there will be generally always, not always, generally there will be the certain time gap will be there, right? After a particular time gap, for the same number of people, you will collect data twice, right?
Yeah, ma'am.
So that way you will
For
be able to maintain.
For example, it's an before and after usage of anything.
You can say before and after can be the case, pre and post after can be the case.
Pre and post are like that.
Pre
Yes.
and post also, right, can be the case of the paired sample status. Means a company has observed the performance of the employees, and then company sends this thing that now the company needs to give the training to the employees. So after training performance, before training performance. So likewise, these are some of the examples to understand the paired sample status conditions, right? So always we will be having one dependent variable, and for the same variable, from the same people, you are collecting the data twice after a particular time period, right? Or during a particular time period, you are collecting the data twice. This is the condition of the paired sample status, right? Is it fine?
Yes, ma'am.
And one more noticeable thing is here, because here we are pairing. So suppose 10 people, I have 10 patients I am having right now. So after a certain period of time, same 10 people I will take, I will consider, and I will take their BP measurement. But in case of independent sample status, if you have seen the results, you have seen there were 216 females and the males were 258, right? So that will be fine because that was the independent sample status. But here in case of paired sample status, your N, both the time should be same, right? And also for the same group or same sample. Now, talking about its assumptions, the first one, the dependent variable is continuous and it is measured twice on the same sample of subjects. I think it is quite clear, everyone. I just discussed this thing. Second says the differences between the scores of variables are normally distributed. And last says the differences between the scores of variables do not present any outliers. So these are the three assumptions of the paired sample status, which we will see in SPSS that how we can check them, right? So hypothesis formulation you can find, generally we can make our hypothesis like the mean difference between the variable scores is equal to 0 in the total population, or the mean difference between the variable scores in different is different from the 0 in the total population, right? So generally this is the hypothesis we are making, but other way around also we can make the hypothesis that we will understand in case of the example which I am taking right now after this, right? So this way we can understand this is the concept of paired sample status and also the what I say, the assumptions of the paired sample status, right? So this is about the conceptual aspect. Now, okay.
Ma'am, please show the previous slide. What we need to report?
Okay, I think I told you this thing previously also. You can, these are the things which you need to report generally. The test value, degrees of freedom, p-value, mean difference in the confidence interval of the difference.
Okay, thank you.
Fine. Okay, I think I have given you this math test sheet, right?
Yes, ma'am.
Yeah. So now you can see we are having the 4 variables listed, grade 1, grade 2. That means this is the one set of the data given to us and second set of data is the before and after. So here I will take the grade 1 and grade 2 for the paired sample status. For your practice purpose, you can use the other set of data that is before and after, right? So suppose we are having the grade of the students before teaching them and after teaching them, the grades are given in the grade 2 column, right? Both the variables are dependent, or you can see we are having the one dependent variable which is score, you can call it, or grade you can call it, right? So this variable is the numeric or the continuous variable. Now we will check the remaining two assumptions. For checking the remaining two assumptions, what you need to do? You need to firstly go to the transform, click on the compute variable. I hope you have located this. Yes, located everyone.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, fine. Thank you, everyone. You can see here, firstly, in the target variable box, your cursor was blinking. So here you need to firstly give the name of your new variable. I am going to create, because it is a compute variable, that means I'm going to create a new variable here. So I'm giving the name as difference. Up to you, whatever name you want to give. You can give according to your wish. Not necessary, you need to follow me, right? Now we want to get a difference of grade 1 and grade 2. So I'm shifting the grade 1 using this arrow button in the numeric expression box. Putting the minus sign from this calculator button and then shifting the grade 2 in the numeric expression box. This is what you need to do till here. Done? May I click on the OK button? Yes. May I?
Yes, ma'am.
Once you will click on the OK, you get a message in the output viewer that this is executed, and you can come back to your file and you can find a new column is added with the name, whatever name you have given. So this is a difference of the grade. Why I have did this thing, because if you can see the assumptions was talking about you need to see the normality and the outliers kind of thing for the difference of these scores, right? Whatever the values is, those two times, whatever two things, whatever variable you're measuring twice, for that variable you need to take the difference, right? So that way I have taken the difference firstly. Now for this difference, we will check the assumptions, right?
Ma'am, sorry to interrupt. I did this, maybe I missed a step. After writing difference, grade 1, then selecting minus, and then grade 2. After that, we have to press OK.
Yes.
But I'm pressing OK, it is giving me a command saying variable name contains illegal character.
You have made any mistake in writing the name of the target variable?
I have written difference the same way as you did.
Okay, if you can share your screen, I can check.
Actually, I'm on a different device. I mean, okay, I'll just try.
You can see, just a minute, I'll show you. You can see my compute variable and try to see what I did and check whether the same thing you did or not.
Yeah, I have done the same thing. It is saying difference in target variable, grade 1 minus grade 2. Yes, exactly the same thing. Man. Difference with the D capital. Yeah.
There is no meaning of caps or small here.
Yeah, I'm just saying that I'm so precise. That's what I'm saying.
Okay, okay, fine. Okay, what about others? Those who are performing?
Yeah, I'm getting difference.
Okay.
Yes,
try
I
again.
have also got.
Okay. Then why Devas is getting this? So, sir, what to do now? Can I proceed?
You proceed, ma'am. Okay.
Or you do? Okay. Okay. Because I think
minus sign might not be taken from the keypad. शायद
even
type
then it
करने
will
में
no problem. If you are using the keyboard of your laptop,
हाँ.
even
I will let me reset and do it again. आप continue करिए.
okay, fine. But in that case, you will be left out, no? For the further processes.
Give me 1 second, ma'am. Let me just- 1 minute. Let me just see again. No, ma'am, if something is wrong, I don't know. I'm getting still illegal character. Difference is coming as illegal character.
Okay.
Give some another name. Give some another name. D or A or something.
Yeah, it is happening now. I gave a different name and it's happening. Thank you.
Is there any variable already available with the same name in your sheet?
No, ma'am, this is the first time I'm doing it.
Okay, fine. Okay, fine. So shall I proceed, right?
Yes, ma'am, yes.
Yeah. So now we'll go to the analyze. We'll go to the descriptive statistics and then the explore. I think now you all are used to of it, right? So you can, I think now easily fine. After this, you need to click on this, and this time you need to shift the difference variable or the new variable which you have created into the dependent list box. Click on the plots, and the same thing you need to do, that is the histogram and the normality plots with the tests. This is what you need to do, right? And then you can press on continue. So I hope I can.
Yes, ma'am.
Yeah. Once you will do on a okay, you will
Ma'am,
be
just wait. Huh?
okay.
Yes, ma'am. Done.
You will get the output like this. So I think now case processing summary is known to everyone. We will check the skewness and kurtosis. you can find these are not greater than 1. These are very nearby to 0, right? So that means possibly we can say that that difference is approximately normally distributed. To ascertain this, we can come to the test of normality. There you can find the Shapiro-Wilks test. Significant value is 0.108. So it is 0.108, meaning is what? It is indicating that your null hypothesis is accepted. If it is accepted, meaning is what? You can call it is accepted, meaning you can say this thing that your difference of the scores is normally distributed, right?
Yeah, ma'am.
Then I think histogram is also looking pretty good. You can put the bell-shaped curve on this, right? So it is pretty good. That means we can comment that it is approximately normally distributed kind of graph. Again, you can see the QQ plot. Most of the data points are following the fitted line. Still, there is certain deviation, but still it is fine. Go down. Outliers are available, but these outliers are coming in the circle form. So you can, I think, recall the thing I said. If outliers are coming in a circle form, that means these are the insignificant outliers. When it is coming in the asterisk form, this is the presentation of the SPSS only, right? So asterisk is indicating that the outliers are significant. So I think 3 outliers are available and shown by the circles, means which are near, or we can say these are closer to the whisker. So somewhere we can say these are the insignificant outliers in the difference of these scores. So almost assumptions are met by the data. Now we are set for performing the paired samples t-test. So I hope I can. Yes.
Yes, ma'am.
Okay. Go to the analyze, compare means, and the paired samples t-test. Done?
Yes, ma'am.
Now I'm shifting grade 1 using this arrow key in the variable 1 and grade 2 into the variable 2. Yeah. Done? Apart from shifting, nothing you need to do. Everything is all set there. You need to only press on OK to get the output. May I?
Yes, ma'am.
Okay. So you will be, I think, getting the output like mine. The first table is the paired samples statistics table. You can find for the grade 1, mean is 6.01. For grade 2 variable, the mean is 7.19. Total 359 respondents or the people are there for both the groups. Standard deviation is 0.48 and 0.88. Standard error of mean is 0.025 and 0.00. When we are talking about the paired samples t-test, so it is pairing of the sample. So always we will get the correlation, which is indicating correlation value is 0.007, and significant is indicating it is very high, it is less greater than 0.05. That means it is indicating correlation is not significant, or relationship between the pair is not significant, right? Coming to the last table, which is indicating the mean is minus 1.17, standard deviation is 0.516, standard error of mean is given, and the last portion you can find, which is the p-value, which is minus 43.150 for the 358 degrees of freedom, and the significant value is 0.000, which is less than 0.05. So you can say this thing that hypothesis for the paired t-test will be rejected. So we can say there is a significant difference in the mean grade before teaching and after teaching, right? Yes or no?
Ma'am, come back again.
I said p-value is less than 0.05. You will reject the null hypothesis and you will comment there is a significant difference in the mean grade before teaching and after teaching? Yes.
Yes, ma'am.
Yes, ma'am.
And when the difference is existing, you can find the grade 1 mean was 6.01. For grade 2 mean is 7.1. Means after teaching, the mean grade has increased. So you can say that teaching is effective. Yes or no? Fine, everyone?
Yes, ma'am.
Yes, ma'am.
Ma'am, just one question now or later. After you complete, then I will ask the question maybe.
Okay, I think this is we are at the verge of completion. So I need to only conclude this thing. You
Mhm.
need to always see this thing. What is the variable given to us? What is the variable type available to us? And what is your purpose? Because generally this question comes, our objective is this. So how we can check that? So you need to be very clear while writing your objectives and hypothesis. They itself will give you the clue that which test will be applicable there, right? So every time, whenever you want to compare the means, you can either go for the t-test or the ANOVA test, right? So ANOVA we will understand, I think, tomorrow, and later on we'll understand the last, that is correlation and regression. So this is the one thing. Paired sample t-test, always you need to see, you will be having the pairing kind of thing, right? So you will be having that, you will be always having the pairing of your variable, that means pairing in the observations, right? For a particular person, you need to collect data twice, and there should be a certain time gap. Generally, this is the clause of the paired sample t-test, right? So I think we are at the verge of the completion of this session. Now our platform is open for the questions and answers if you are having any.
I just had one question, ma'am. There is on the left-hand side in SPSS, there is a drop-down called notes. So is it something which gives us some kind of cue of what we can write as a summary, like what we are interpreting, we are getting it. But is there a template in which we can use and then add on further to that? Is that what notes mean?
This is you're talking about?
That's right, ma'am.
Okay.
What is the purpose of this is what I'm asking.
You can see once I'm selecting the title, it is lending me here. This is the test, right? Here you can make the changes if you want. Suppose you are clicking on this. So using your dashboard, if you want to make changes that you can do. Similarly, notes, if you are coming, you can double click on this. So you can find that, just a minute. You can find once you are coming on a test. Okay, just a minute. Once you are coming on the notes, also I think it is not giving you anything. I have clicked on this, yeah. That way, once you are clicking on this type of notes are coming to you. Here you can write the things if you want. These are editable things.
Okay. So basically what I was asking was, is there some kind of standard template of inference which is coming up, and there we can add more to it, so it saves us some time? So like what you're narrating as an analysis, does the machine also give the analysis as a cue, and then we can further build on that, is what I was asking.
No.
Okay.
No. Usually, sir, means it is like in whatever journal we are writing, for whatever journal we are writing the paper, we can see that pattern of writing of the previous authors. That is giving us the clue. And for the thesis, if we are talking about, so generally you need to report, say for example, whatever test you are performing, you need to report that test statistic value, degrees of freedom you need to report, the significant value you need to report, and the confidence interval value you need to report. And in appendices, you can put the actual figures. There is no problem in that.
Okay, ma'am. Thank you.
Yeah. Anything else? Okay. No other question? So shall we call off the meeting for the day?
Yes, ma'am. One request which we made yesterday also about the slides. Today also, if you are trying to practice with the slides, it will help. Unless there is any restriction, if that can be shared. If there is no restriction, that can be shared. That's all.
I'll try to share. So the thing is that I am so much occupied now. I'm having one more class from all that has started. It's almost.
No, I
16.
appreciate that. So whenever
Yeah.
you get time, if it is possible tomorrow.
I'll try and I'll share with all of you. Right?
Thank you very much, ma'am.
Yeah. Thank you so much. Anything else?
No, thank you.
Thank you so much, ma'am. Okay, fine, everyone. So we are meeting tomorrow for the next session. Tomorrow I am having external viva of students at the institute, right? So possibility is that maybe I get little late. Possibility, not sure. So maybe 5-10 minutes late means I'll be late. So I'll put the message in the group. Yogra sir, are you there?
Another thing, ma'am, is that the SPSS data sheet which you share, if you share it slightly in advance, then we can kind of be ready with that. Otherwise, sometimes, putting that takes some time. So that's a request.
Yeah, I'll try to do that, sir. Actually, thing is, examinations are going on, the college meetings are going, so sometimes it happens we got late. I'll try
problem.
to do that.
No problem. No.
Yeah, fine. Anything else? Yes, Yoga sir, I said tomorrow I am having the external vivocy of the students in the institute. So possibility is there. Probably I'll get late by 5-10 minutes. Not sure. I'll inform you accordingly. Yeah, fine. Thank you so much, sir. So thank you everyone for your patience listening to me and doing practice along with me. So it's all from my side for the day. We are meeting tomorrow for the next session. Thank you.
We can start tomorrow at 6 o'clock.
Thank you, ma'am.
If that's
Sorry,
okay.
sir.
I'm saying that we can start at 6 o'clock tomorrow. It will give you some time also. So if that is okay by everybody.
I think that you can say I do not have any problem. Otherwise, as Yoga sir said, Yoga sir, it is fine if we can start tomorrow by 6. ठीक है. Thank you so much, sir. It will give me even time for breathing.
Yeah, that is important also.
Yes, it's a breathing.
Long session, so you should also.
Yes, thank you so much, sir. Thank
Okay.
you.
6 o'clock we'll meet, ma'am, tomorrow. No problem.
Fine, thank you. Thank you, everyone. Take care. We are meeting
thank you.
tomorrow for the next session. Bye.
Bye.
Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
Thank you, everyone.